Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, collecting chocolates. This problem is a bit interesting. If you solve it via via a brute like via the standard process of the first coming up with the brute force solution and then optimizing it, you will find this problem very easy. But if you do other way around, this problem might feel a bit hard. So with that, let's get started. The problem states that you are given a zero indexed array nums representing the cost of n different chocolates. Each chocolate is of a different type, and the chocolate at ith index is at ith type. So basically, zeroth index has zeroth type of chocolate, and it cost nums of zero. Right now, in one operation, you can do the following. You can do the following, which will incur the cost of x. So what you can do, you can say that ith type is now moved to I plus 1th type, and you can do this for you have to do this for every I simultaneously. And for the last index, which is I equals to n minus 1, because it doesn't have I plus 1th type, you will change it to the index 0. Right now, you can do this operation any number of times as you want. You have to return the minimum cost to collect the chocolate of all types. Right, so let's take an example. Let's say the array is 2115. It means the 0th chocolate cost 20, first chocolate cost 1, second chocolate cost 15 initially. Right, x is 5. It means if you apply the operation one time, you will be incurred a cost of 5. Now, initially, as we know that 0th chocolate is the 0th position, first chocolate is the first position, and second chocolate is the second position, we can simply buy the first chocolate here without applying any operation. So if you buy the first chocolate, you will be incurred a cost of 1. So at cost of 1, you have first chocolate with you. Now, let's say you apply the operation. So initially, this was the state, like 0th chocolate was at 0, first chocolate was at first, and so on. Now, when you apply the operation, they are saying that ith type will move to I plus 1th type. So 0th chocolate will move to here, first chocolate will move to here, and second chocolate will move to the first index. So this will be the state now. In other words, it means that second chocolate will now cost 20, 0th chocolate will now cost 1, and the first chocolate will now cost 15. Now, what you can say is, okay, I will now buy just 0th chocolate. So if you buy the 0th chocolate, you will again incur the cost of 1. So what is the total state now? You have already bought the first chocolate at a cost of 1. Then you apply an operation which will take you a cost of 5. And then you buy the 0th chocolate again at a cost of 1. Now, let's say you apply the operation again. Again, you shift everything. 2 will move here, 0 will move here, and 1 will move there. So the state is 1, 2, 0. Again, here you will say that I will buy the second chocolate here, and it will cost you 1. So total cost now is 13, and you have buyed all the chocolates. 0th chocolate, you have bought the first chocolate in the first iteration, 0th chocolate in the second iteration, and second chocolate in the third iteration. So you have all the chocolates of all the types, and you you require a cost of 13 to collect all the chocolates, and this is the minimal cost that you can get. If you try any other possible combination, you will not be able to get a cost less than 13. One simple way to look at it is, if you buy the chocolate at any other position, the cost would itself be greater than 13 at that position. So you will not be getting any other uh, optimal choice to buy the chocolates, right? So hence 13 is the answer. So hope the problem statement is clear. Now, how to solve this? Again, if you haven't thought about the brute force solution yet, I would strongly encourage you to pause the video and try to think of brute force solution by yourself first, because that's where half of the problem is done most of the time, right? So hope you thought about it. Now, what is the brute force solution for this? Notice that what operations we can do. We can shift the chocolate type one by one. So what we can say is, okay, let's say this is the initial configuration, and let's say x is equals to 2. So it means one operation will cost you 2 units. Now, if you apply the operation one time, you will be going to this. So basically, 0 will shift to 1, 1 will shift to 2, and so on and so forth, and finally 4 will shift to 0. So if you apply the operation one time, you will be getting here. So basically, you incurred a cost of 2, and this is the state now. Again, you can apply the same operation, you will incur a cost of 2, and this will be the state. You can apply the same operation again, and the state will change. finally you can apply the same operation again and the state will change. Now let's say you want to apply the operation again. What will happen? 1 will move here, 2 will move here, 3 will move here, 4 will move here, and 0 will move here. So this state is exactly similar to the original state, right? So if you want to buy a chocolate here, you could have already bought the same chocolate here, right? Let's say you are saying that okay, I will now buy the second chocolate here. So it doesn't make sense to buy the second chocolate here because you can get the same chocolate at same price at this configuration. So you can skip having this 8 operations here, right? Or eight extra cost here. So that's the first observation. Basically, we will only be caring about n number of operations or n minus 1 number of operations, right? After that, will applying any more operation will not be beneficial because every state will now repeat. And if you want to buy somewhere at that particular state, you could have buyed the same chocolate previously at a lesser cost as well. So that's the first thing. Now let's say you have this all n minus 1 state. Now what you need to figure out, you need to figure out that okay, where will I buy a chocolate of particular type? You can say that okay, I will buy the first chocolate here. I will buy 0th chocolate here, right? Then I will buy fourth chocolate here, and then I will buy, let's say, third chocolate here, and finally I will also buy second chocolate here itself, right? So if you have said this, basically what you're doing is you have like n minus 1 places, and you are assigning like assigning these 5 values to one of those n minus 1 places, right? So let's just try to visualize it with the table. So let's say you have this 4 operations with you, or 5 operations with you. You have to assign which chocolate will you buy at which state. So you can say okay, without applying any operation I will buy C1. Now without applying, like after applying one operation I can buy C0, and then after applying 4 operation you can buy C4 and C4 and C3, and so on and so forth, right? Now this is good. What is the, like, what you can say is I will try every possible combination, and for a single combination I already know what is the cost. So basically, let's say you said that okay, I have this configuration, I will buy C1 at 0. So you can just take 1 and add it to the result. You are saying that you will buy C0 at 1. So what you can do, you can apply the one operation and you can see where 0 lies and add that particular cost. Now you're saying that at operation 4 you will buy C4 and C3. So you will apply 2 more operation and you will see okay, I will now buy C4 and C3. So C4 and C3, right? So, or sorry, C4 and C3, you will buy the chocolates here, right? This is just an example. So now, what is the total cost? Total cost is 1 plus 1 plus 7 plus 9 plus uh, you have gone all the way to C4, right? So you have incurred all these costs. So at first at first operation you incurred a cost of 2, and then to go to C4 you have also incurred 3 extra plus 2 cost, right? So this is your total cost that you have get. Now you you can do this cost thing for every possible configuration here and just take the minimum, and that will be your answer, right? Now what is the time complexity of the entire solution? First of all, finding out the cost of a particular configuration, let's try to find out the time complexity. So what you are doing is you are trying to figure out where, like, the to figure out the cost, you need to figure out what's the value of a particular chocolate was after applying some operation, right? So in total you can apply n minus 1 operation. In one operation you require to iterate over all the n chocolates so that you can shift them to something else, right? So in one operation you require n time. You have total n minus 1 operations that you can apply in worst case. So this is the total complexity in which you can apply all the configuration. So basically you can get all this array in this amount of time. Now after getting this array, the thing is simple. You can just you have to just select which one you are buying one by one. So that will take order one operation for each of them. Basically, for each chocolate you will iterate over the respective operationed array, and select the one which you want. So this is the total time complexity. You can just ignore it because this is the dominating factor. So total time complexity to find the cost after you get a configuration is n into n minus 1. Now, how many configurations you can have? So number of configuration that you can have is somewhere in the order of NCR. Now, why NCR? Because what you can say is, okay, I have n minus 1 places, right? Or n chocolates. I have n chocolates and I have to divide them into n minus 1 places. So basically, I have to put n minus 1 bars. So you can say that, okay, how many ways are there to put these bars? So total ways will come out to be somewhere NCR, where n and r would be either a subtraction or addition of this factor of n, right? So we are not going to the exact proof, but it will be in the order of NCR. Now the value of this is very huge. So this can surely fit in time complexity because n is very small, 1000 only. So this n square will work, but NCR will be very huge. So we can't afford this. So we need to remove this itself. Now where exactly this was coming from? This was coming from the fact that we are iterating over all the configuration that is possible to figure out the minimum possible cost, right? So if we have to remove this, it means we have to skip iteration over all the possible configuration. Now, how you can do that? Just think about it. You have applied four operations. Let's say you said that, okay, I will buy all the chocolates up till the fourth operation. So you have applied four operations already. Now, because you have applied four operations, let's say which where will you buy C1 or C0 or C3 or C4? Basically, the operation where you will buy the chocolates is something you can choose independently, and because you have applied all the operations up till 4, you are saying that each of these chocolate will get four different values during its lifetime, right? So what you can say that, okay, I will just pick the one which have the minimal value across the lifetime. Again, just to repeat, we are saying that we are applying four operations here, right? Just for this example. So instead of dividing these chocolates across the operations, what we can simply say that, okay, because we are applying four operation, each of these chocolates will have four different values or five different values during its lifetime, and we will just pick the one with the minimal value because anyway we will be applying four operations, so we have to pay the four cost here. Like we have to pay all this cost here. So if we are paying all this cost, we will take the maximum advantage of it and we'll select the one which have the minimal cost across all these five configurations, right? So you will do the same for all the chocolates. So for first chocolate, let's say you figure out that, okay, one is the minimal value, so I will say I will buy first chocolate where the price was 1. Now it doesn't matter where the price was 1. You can figure it out as well, but it doesn't matter in this problem where the price was 1. Now similarly, what you can say that, okay, for the second chocolate, what I will do, I will have again five different choices. So this is the first choice, this is the second choice, third choice, and fourth choice, and the fifth choice. Now what you can say that, okay, among these five choices, I will again consider the one which have the minimum value. So you can just consider this one as well. So similarly, you can consider all other chocolates, and finally, you will get the same price or the price of this configuration in just order and time. Oh, sorry, order n square time, because again, it will be requiring you to figure out all this configuration. So it will be you will require order n to n minus one time, but now the number of configurations reduced. Previously you had this NCR configuration, but now you're saying that all it matters is how many operations you are applying, right? So if we are applying only four operations, it means we have to get over all the four configurations. So how many different kind of operations you can apply? You can say that, okay, I will apply only four operation, I will apply only three operation, or I will apply only two operations, one operation, or zero operation, right? So number of now this NCR is reduced to number of operations you are applying. So basically it will be in order of n minus 1, right? So the complexity is still order of n cube, right? Which will again not pass because n is 1000. So n square will pass, but order of n cube will not pass. So you have to optimize this further as well. Now, I would strongly encourage you to pause the video and try to think of how you will optimize this order n cube to order n square, or something lower if you want. Hope you thought about it. Now notice that what we are like, let's say you have applied only three operations, right? So do you need to iterate over, or do you need to figure out all the operations or all the arrays for this three operation? The answer is no. Basically, this thing you can just calculate once and keep it with you, right? Now once you have all this array, now you can iterate over this n different arrays and figure out what is the cost in order n time. So basically, this part will be something which will go to pre-computation. You will compute this beforehand, and you will require order n square time for that pre-computation. Now once you have once you have all this array built out, for each type of operation, what you will do, you will again, like, let's say for each type of operation, what you need to do is we need to figure out where exactly one has the minimal value, so that you can simply figure out by doing a prefix max kind of, a prefix min kind of structure. So that will take again order one time for each chocolate, so order n time for all the chocolates. So complexity will now be order n square, right? So let's just take one example and just iterate over this entire algorithm once, right? So let's say we will take the same example, right? So we have these five chocolates, and we will pre-compute all the iterations. Notice that there will be only four iterations or four operations that you can apply, because on the fifth operation, the configuration will again be same as 0 1 2 3 4, and hence it will not be beneficial for us to buy something at that particular configuration. So we have applied this four operation, and this will take order n square time in total, right? Because what we are doing for each operation, we are just iterating over all the chocolates and shifting them one by one, right? Now once you have this, we need to now figure out what is the minimum cost to buy all the chocolates. So we'll start with uh, operation 0. Basically we'll say that, okay, we'll not apply any operation. Now get me the total cost of buying all the chocolates. So let's say you have this array which will store you what is the minimum cost of each chocolate that you have seen till now. So initially you will say that, okay, I have only seen that the first, like, I am not applying any operation, right? So if you're not applying any operation, this is the only thing that you have, right? So what you will say that, okay, I have only seen this particular configuration, and hence zeroth chocolate will now have minimum cost of 2. First chocolate has minimum cost of 1. Second chocolate minimum cost of 7, and so on and so forth, right? Now uh, what you will say that, okay, for this particular configuration or for operation 0, minimum cost that I can get is 24, right? Now why 24? Because you know that you are not applying any operation, so you will not be incurring any cost of this particular operation, so no x is involved, and you have to buy all the chocolates, and this is the minimum cost of each of this chocolate that you have seen so far. So you will just buy 0 at cost 2, 1 at cost 1, 2 at cost 7, and so on and so forth. So if you sum them all up, it will be 24, right? Now operation 0 is done. So again, what is the time complexity of this operation 0? You are just iterating over it and just summing it up. So order and time for operation 0, right? Now similarly, you will now try operation 1. So what you will say that, okay, now I'm saying that I will do up till first operation. So basically you have also seen this particular configuration. Now because you have also seen this particular configuration, you know that 0 can also have cost of 1. Previously 0 had minimum cost of 2, but now you are saying that 0 has also cost of 1. So what you can say, I will just take the minimum and say that, okay, now up till operation 1, I have seen that 0 has cost of 1. Similarly, for 1, initially, previously the cost was 1, minimum cost was 1. Now you are seeing that for 1, the cost is 7, which is greater than the 1. So you will say that, okay, minimum cost for 1 that I have seen so far is 1, right? And similarly for others as well. So for 2, you have seen 7 previously. For 2, now it is 9. So again, 7 is smaller, so 7 is there. For 3, initially it was 9. Like the minimum cost that you have seen till now was 9. But now because of a new operation, for 3 you have seen a 5 as well, so you will just take the minimum and you will be getting 5 here, right? And similarly for 4, you will see now 2. So this is 2 is smaller, so we will say that okay, minimum cost that I've seen for 4 is 2. So now what is the total uh, result for after applying this one operation? Total result now is 1 plus 1 2 plus 7 9 9 plus 5 14 plus 2 16 16 for this thing. Now you have applied one operation as well, so you have also incurred a cost of 2, so total cost is 18 now, which is smaller, so you will just update your answer to 18, right? So let's do one more iteration, so you will see. Okay, let's try operation 2. Now again, what is the how much time you have spent for figuring out the stuff for operation 1? You have just iterated over this particular array and taken the minimum over all the values one by one, so that will take order and time, and then you have done the sum, that will also take order and time. So in total again you have done the same order and operation. Now for operation 2, again the same thing, you will see another new variation. So you will again try to take the minimum values across all. So you will say okay, for 0 I have seen 1 as the minimum till now, and now it is 9, so basically 1 will stay the minimum so far. Now for 2, initially previously it was 7, right? Now you will say that okay, for 2 I have seen a 5 as well, so minimum cost for 2 is now 5. And similarly for 3 it will be 2, and for 4 it will be 1. Now this is the cost that, this is the minimum cost for each of the chocolate across its lifespan. Notice that this one denotes that 0th chocolate had a minimum cost of 1 across these three different values. And similarly this 5 denotes that second chocolate will have, like, second chocolate has various, like, three different cost, and across three different cost 5 is the minimum one. So again, what is the answer for operation 2? You will sum them all up, and now you will also add 4 here because you have applied two operations. So what is the sum? 1 plus 1 2, 7 9 10, and plus 4 14. So again it is smaller, so we will take 14 here, right? Now finally, you, let's say you say that okay, I will apply one more operation. So again the same thing, you will just take the minimum. This is the array you will get if you apply the minimum across all the things. So uh, let's just take 2 as an example. So initially 2 was 5, and now the value of 2 is 2. So you will just take the minimum and you will get 2 here. So the cost of this particular configuration would again be 1 plus 1 2 plus 4 plus 2 6 plus after 6 you will also add 6 here because you have applied three operations, right? So 6 plus 6 12, so which is smaller than 14, so we'll get 12. Now the final one, this one will have a cost of 13, so this is smaller, which is greater than 12, and hence 12 is the minimum cost and it is the answer. So for each of, like, for calculating each of the operation, you take order and time, and as we have discussed, you can apply the operation n minus 1 number of times. So basically for finding out the result, you will take order n square time as well, right? So this is the overall algorithm. Hope this entire solution makes sense. I am not showing the pseudo code because we have already gone through the uh, complete dry run, and it just preparing these arrays and figuring out the minimum. So pseudo code would be exactly similar to this. I would strongly encourage you to pause the video and try to code this entire solution by yourself and get it submitted as well. Next we'll be looking at the code. So in code, what we have done is we have written a shift right function that will just shift everything to the right. So basically, it will help us to get this array from the previous array, and similar, or basically get from this array to this array, and so on and so forth. So basically, this will just shift one everything to the right. Now, what we have done initially, we had said that okay, chocolate 0 is at position 0. Now we haven't applied any operation till yet, so we take the operation cost as 0. Initially we have taken the result as very huge value, and we know the min cost now. So basically initially min cost would be exactly equals to this. Basically we are saying that chocolate 0 has a cost of 2, chocolate 1 has a cost of 2, cost of 1, and so on and so forth. Now after that we are trying to apply the operation a number of times, or uh, inside this what we are doing, we are uh, trying to sum everything in the min cost. So that is the total cost after this many number of operations, and we already know what is the how many operations you have done. So operation cost will contain the cost of all the operations. So notice that what in this particular algorithm, what we have done is we haven't calculated this entire thing beforehand, because calculating this entire thing beforehand will require you order n square space. So I was just trying to optimize this complexity of space complexity from order n square to order n. And the reason why we can do this is because you don't need everything at once. So at when you are dealing with this particular array, then only you will need this particular array, right? After that, this array is not useful at all, right? Similarly, when you are dealing with this particular array, or you are dealing with operation 2, you will only need this particular array. So we can simply optimize the space complexity from order n square to order n. And hence that's what we have done. We have just simply maintained min cost, and we haven't maintained these shifts beforehand. So we just calculated the result as min of result comma val plus operation cost. Now we shifted the order, right? So now the chocolate one will every chocolate will shift right one position, and because we have shifted, we also added x to our operation cost. After that, we have iterated over all the chocolates, and for each of the chocolate, we know this was the previous minimum cost that you have seen. Now the chocolate 0 is at this particular position. So the cost of chocolate 0 will now be this. So you just take the minimum across these two. That will be the new minimum cost of chocolate 0 or chocolate j. So after this, minimum cost will again contain the minimum possible cost so far after applying OP number of operations, and you'll just take the sum and calculate the result, right? So this entire solution will work in order n square with order n space complexity. Now let's just look at the shift right quickly as well. So this is very simple. We just, as discussed in the problem statement, we created a result array and we shifted everything to the right. So result j will be equals to v of j plus 1. And finally, the last element of result would be equals to the first element of the v. So hope this interpretation makes sense. If you have any doubts in this particular problem, feel free to post them in the comment section below. I would have to answer. If you like the video, give it a thumbs up and do subscribe if you're not already. And I will see you in the next one. Thank you.